Hello, today I'm going to talk to you about concentration and then dilutions. So concentration is probably something you're familiar with, but maybe you haven't thought about in terms of chemistry. So the example I've shown here is a can of orange juice concentrate. So this is like all the parts of juice that aren't water really crammed into that one little can. So you add that, and then you add 3 cans worth of water to get a normal concentration of orange juice. All right, so the concentration is basically how much of that substance you have in a given amount of solution. All right, there are lots of ways to express concentration in terms of mass or volume or number of particles, but the one we're going to use solely in this class is number of particles, and we call it molarity. All right, the molarity of a substance is how many moles you have per liter. All right, and it's per liter of solution. So the total volume of the stuff you get after you mix your solid into your water. Usually water is our solvent in chemistry. So the symbol for molarity and the units are capital M, and that means the number of moles divided by the number of liters, or sometimes we just say moles per liter. Okay, so if we have the molarity, or we want to find the molarity of a solution that we made by putting 87.7 grams of sodium chloride into 0.250 liters, or to make a total of 0.250 liters of solution, then first we need to know, because we're talking about in terms of number of particles, so first we need to know how many moles that is, right? So this is a review, but just to review, NaCl, you would add up the mass of sodium from your periodic table plus the mass of chlorine to get 58.443. That's how many grams of NaCl are in 1 mole. All right, and since we put in 87.7 grams, if we do our dimensional analysis, you get that that's 1.50 moles. All right, so now we take our number of moles and plug it in for moles, and our number of liters and plug that in for liters. So our equation is 1.5 divided by 0.250, and we get a molarity of 6. Okay, so that's really all you need to know. I will not give you the equation for molarity, because it really is kind of the definition of concentration for us, but it's just the number of moles divided by the number of liters. All right, so now let's do one that's a little bit different. So let's say we want to make 2 liters of a solution, and we wanted to have a molarity of 1.5, right? So if we want to figure out how many grams of solute we need, then you would start with your molarity. All right, we have that same equation we did before. That 1.5 is our molarity, and that's going to equal some number of moles divided by the number of liters. Okay, so 1.5 is going to equal X, or you could just write moles, it doesn't matter, divided by 2. So to get that by itself, you have to multiply both sides by 2. So X is going to be 2 times 1.5 molar, which is 3 moles of NaOH. And now we could also do that with dimensional analysis, and I show you this if you get to that last unit with solutions and reactions. You'll use molarity actually as a conversion factor. So what that means is we could start with our 2 liters, right, and then use the fact that there's 1.5 moles per liter to get us to 3 moles that way. Either way works. You can just use the molarity equation, or you can use molarity as a conversion factor. Either way, now that we know we need 3 moles, the question asks us for grams, so then the last step we'll do is to use the molar mass of NaOH to get from 3 moles to the number of grams that we would need to make our solution. Okay, so now let's talk about dilutions. Sometimes you want to make your solution from the solid form, so you need to know a number of grams, but sometimes you might have a solution already prepared that's more concentrated, and you want to dilute it like we did with the orange juice to get something that's useful for what you're doing. All right, so this question is, what is the molarity of a solution prepared when 75 mils of a 4 molar KCl solution is diluted to a volume of 500 milliliters? Okay, so the equation for this is M1V1 equals M2V2. I swear, out of all the things I learned in high school chemistry, this is the equation I used all of the time in graduate school. It's like cemented in my brain. So M1V1 equals M2V2. M just stands for molarity. V is the volume, all right? So our initial volume is 75 milliliters, and our initial molarity is 4. Okay, so that will be our M1 and our V1. And then our final volume is 500, and we're trying to find our final, so that's your initial, and then 500 is for your final. So what we want to do is plug those in. 75 times 4 is going to be equal to whatever our new concentration is times 500. Okay, so we divide both sides by 500, and you get a molarity of 0.6 molar. Okay, these are, like I said in class, relatively straightforward calculations. You just have to use the equations.